Hello everybody, welcome back to another code review. This time we're going to be looking at a project called Echo, which is actually a C# project, and it was a game that was made for the Jiggle Jam over 4 days, and apparently the Jiggle Jam is a game jam where you need to use like spring bones or some kind of other like jiggle physics, I guess. And yes, I know what you're all thinking now, but this project is from Papa Laquavius, so I've linked that developer's itch.io page in the description below, and I've also linked Papa Laquavius's Artstation. So go ahead and check that out. The developer would appreciate all of your support, and thank you in advance to the developer for submitting this project. So the first thing that we're going to do is we're going to go ahead and run the project, and we're going to see what's all going on. Now, before I do that, I'm actually noticing something really interesting. There's a very nice lighting effect going on here, so maybe we'll spend some time investigating that, but let's get right into the game first. Okay, so here's our main menu. I'm going to go ahead and just click into this play here. Got a very nice scene transition. And I've got this little glob here, and you can see the glob has some very nice soft body physics here. Now, I think the developer made a note that this is using a Springbone 2D, so we'll take a look at that in a little bit as well. Oh, there's a sign. Wait, there's an E here. Helpful sign. Welcome to Echo Technologies. Say goodbye to your old self and say hello to a brighter future. Say goodbye to your old self and say hello to a brighter future. You already said that. You already said that. All right, so we may be in a situation here where I'm going to get stuck on the first level, but we'll see. There we go. Okay, I just opened up the green lever. Perfect. Okay. All right, so we've got a pretty interesting puzzle platformer level here. We've got a red door, which probably needs a red key. Is there a key anywhere on the level? So there's apparently an interesting mechanic in this game where the dialogue is tied in with some NPC villagers or townsfolk, I guess the developer calls them. And apparently they have different dialogue or schedules or something as you play the game. So the theme for this jam was something is a bit off. So I think there's supposed to be a surreal element to this game. Again, with these code reviews, I don't have time to play the full game, so I'm not going to be able to really see the full vision because we're mostly interested in the technical aspects, but I think the game is pretty interesting. Oh, and I got stuck. Oh, thankfully R restarts the game. That's always nice. Let's see. There's a villager over here. Pink slime. You know what I mean? There is no way of stopping this. Okay, so one thing that we're going to probably want to take a look at is how the dialogue system is being done. Oh, I'm getting attacked by the slime. Oh, are we in a... Oh, interesting. So I got sent back to the beginning of the game after talking to that slime. Is there a way to exit out? So I think, you know, not to offer game design feedback, but I think it would be valuable to have a way to skip dialogue here. But again, this game was made in 4 days for a game jam, so it's not reasonable to expect that every single quality of life improvement exists. Although I would say, like, if you are making a jam game, the quality of life is actually very important. It's more important, in my opinion, that your game feels good to play than whatever content you want to add. If you have a choice when you're in a game jam between spending your remaining time polishing the game or spending the remaining time adding more content, my opinion is that you should always opt for polishing the game and making it feel and look good. And the other thing that tends to happen with game jam games as well is that people are tended to make their game longer, and so they add more content, but it's just more of the same. And so what a player ends up doing is just they end up doing the same thing over and over and over and over again. And it's like, if you don't have anything new to show the player, it's okay to make a short jam game and just polish the heck out of it. And even if your game only lasts 3 minutes, like it takes 3 minutes to complete, that's not really going to negatively affect your ratings at all. People are not, you know, expecting to get multiple hours of enjoyment out of a jam game. They want to see your concept. They want to see it executed well. And they do feel better, I think, players, when they finish your game. If you can get your game finished right before the moment where the player gets bored of your jam game, that's perfect, because that's going to maximize their enjoyment of the game. So it's a very intriguing game. Let's take a look at a couple things. First, I'm interested in how this lighting effect is being done. So I think 2D lighting is being used in this project. So if we look at this title screen here, we've got some lights, we've got the sun, so toggling that off gives me that. We've got light occluders. That appears to just be what? It's an occluder polygon, and you can see that it's kind of outlining all of the sign here. So that's pretty cool. It's very nice. And then the way that the developer has done these light rays here, let's see, we've got the sky. So this sky appears to just be a texture rect here. Oh, that's like a solid color maybe. Let's see, get rid of the clouds. Okay, so this sky is just like a gradient, I think, or maybe it's a solid texture. Yeah, it's a solid texture. The clouds are a different texture. We've got trees here. That looks very nice. But the God ray here, this is apparently, yeah, this is just a texture here. So we've got the shader material, godray.shader. Okay, very interesting. So I wonder if this God ray shader was, yeah, taken from Godot shaders maybe. So that's a great resource, godotshaders.com. If you want to look for a bunch of pre-made shaders that you can readily use in your games, it's a great place to get it. So that's a very effective use of the God ray, I think. But let's go ahead and take a look at the player. So I'm just going to go ahead and open up the player here. And let's take a look at what we got. So we've got, let's see, there's a bunch of points in here. Oh, they're bones. Let's see. So we've got a soft body 2D. I see. Okay. So we've got a soft body 2D here that is a rigid body player character underneath. Oh, interesting. I wonder why the rigid body is not the root node. Let me take a look at something real quick. I'm going to look at the game. I want to see if this player root position is changing at all. So if I go into play here, let's just see. So if I move the player, I'm going to go to the remote scene tree here. Let's take a look at where the player is in the remote scene tree. Player. So this player position is 38, 311, and the player character position is 232 by 8. So that may present some problems. It's kind of weird. Is this player position moving when I move? Let's see. So I'm going to move a little bit. That player position is not moving. So you can see that the player position starts there, but then this player character node, when I select that, that's the thing that's actually moving. So that's kind of awkward. I think that you can get into a bad situation when you're doing things that way. Maybe there's a good reason for it, but it's kind of awkward that this player node is not representative of the actual player's position, because that is going to be under the player character node. I don't know exactly what this player node is supposed to do. It looks like this player character is its own scene, and so is this player. Maybe we can figure this out. And I forgot, I actually need to open up VS Code, so let me do that real quick. This video is sponsored by me. If you want to learn how to build a complete game in the Godot engine using either C# or GD script, check out the links to my Udemy courses in the description below. All right, so I've got this loaded up in VS Code now. So this player root script is a player prompt handler. We've got the ePrompt and ePrompt.visible. So that makes sense. So it looks like what's happening every process frame is this game manager can interact flag is being set somewhere. And we've got a big game manager script here. So maybe we'll take a look at that in a little bit. But this can interact is being set to true here. So this is certainly one way to do this. I would avoid global state personally for this. And what I would do is create like an interaction area component. And then what you could do for the player prompt handler is you could make this a component and put that as a node underneath this player character. And then you would have an interaction area component that you could add to all of your interactables. So that's a very good way to use composition in this case. I'm not going to spend the time to actually implement that because we have plenty of other things to look at. Generally speaking, I don't know if it's a great idea to use a global state for the interaction state. And this process method ultimately becomes unnecessary if you switch to using components and like area detection. But it's fine. It's a game jam game and it works. And it working is the most important part. So the player prompt handler, that's basically what the player node is. So that's the script at this level. And that's providing the necessary functionality for interacting with things. So let's keep looking at this player character soft body. So let's actually just go into the scene for this player character. Got the soft body, we've got a bunch of bones here. And admittedly, I don't know a whole lot about how the bones work with respect to the soft body 2D. But yeah, I would say generally it works very well. I wish I could offer a little bit more insightful commentary about this soft body setup, but I really don't have any experience with soft bodies. But that's what it looks like. So if you're curious to see what the player looks like, we've got all these spring joints here, I think is what it's called. Is this a spring joint? Or it's a damped spring joint, yeah. And then we've got a bunch of bones. If I were to guess, the joints are all affecting the different bones or are all providing the bone functionality. Yeah, I'm not even gonna really pretend to know what's going on there, but it obviously works. Now, one thing I'm noticing is that this soft body 2D here, let me take a look at this. So we've got the texture here, this slime blue, but we've also got this shader material here with an outline color. Now, I don't know precisely what that's doing. I'm going to go ahead and just change this really quick. I want to see what this outline is doing. Okay, so we've got that outline. So I think it's a good idea to add an outline shader to this, but what I would probably do is I would honestly maybe consider removing the outline from this texture here and doing that outline with the shader itself, because this does become rather pixelated and squished with the rest of the texture. So if I run the game again, yeah, you could see that because there are portions of the texture that have the outline, it's getting deformed with the rest of the body. And so that means the outline looks kind of weird. I wonder if you just increased this size of the outline here on the outline shader. So I go here and I go to outline thickness and I turn that up. I'm wondering if that's going to give the impression of more what I'm talking about. So that's kind of better, although I think it's still, because it's still being drawn as part of the texture before it gets deformed, I think maybe that's still causing problems. So let me actually try something really quick. I'm going to try instead to use a canvas group for this texture, and that might actually completely break something, but I'm going to go ahead and just add a canvas group here. And the first thing I'm going to do before I do anything else is I'm just going to try to, oh, this is a GD script. Okay. But anyway, I'm just going to try to put the canvas group there, and I just want to see if I break anything when I do that. And then if that doesn't break, then what I'll do is I'll add an outline shader to that canvas group and we can take a look at how that works. Okay, I don't think that broke anything. So let's go ahead and do this. I'm going to copy this material and revert it from there. I'm going to put this on the canvas group. Now I am going to need to make some changes to this outline shader, and I hope this is not used anywhere else. Actually, I'll just make this unique to guarantee that it's not used anywhere else. I'm just going to convert this to a canvas group shader really quick. So I'm going to take this shader type canvas item render mode unshaded. We're going to grab the screen texture. All right, so I've updated the texture to be compatible with the canvas group shader. So canvas groups require a specific type of approach to writing the shader, but I should be able to change this outline thickness. Now you're not going to see it that well in the editor because of how the canvas group works, but I'm going to change that outline thickness to 2. And now what should be happening, at least the goal here, is to have made the deformation of the soft body texture separate from the outline shader that's being drawn around it. And the way to do that is to use a canvas group. So you can think of a canvas group as capturing the texture that gets drawn on the screen that you can then add outlines to. And so that's really useful if you're deforming a sprite but want to keep a crisp outline. Make it a child of a canvas group and then apply the outline shader to the canvas group instead. So let's see if this actually gives a better result or not. Yeah, so see, the thickness is really high, but do you see how that creates a much smoother outline as the thing is being deformed? So if you're trying to, again, do a deformation but have an outline around it, use a canvas group for that, because the canvas group will apply the shader after any sprite deformations have happened. So let's go ahead now and go into some of the dialogue. And I actually don't know where this dialogue system exists. So we're going to have to poke around in the code base a little bit and see what's going on. I think a good candidate is to look at the interactable sign in here. And this is actually a very small script. That means that there has to be some kind of dialogue system interacting with this in a different way. So we've got interaction area. Oh, it looks like there is an interaction area 2D here. So yeah, again, going back to what I said, you could easily convert this into a component and sort of genericize or generalize these area entered and area exited for your interactables. One thing I'm noticing in here, setting aside the dialogue thing, is that this is checking for the body name. I think that this is generally very brittle. So if you need to check the type of the body that's coming in, what you could do is you could just say if body is player prompt handler, right? And then you could do the same thing here. If body is player prompt handler. If you're checking the name, all it takes is for somebody to go into the editor and slightly change the name, and like this whole code will break. So this is a much safer way of doing this. And also, especially in C#, this is now using a symbol, which means that if you were to rename the symbol, it would be renamed here, right? So it's not just a raw string. But anyway, this is not giving me any clues as to where the dialogue is happening. So let's just take a look through our scripts here. We've got our game manager. Is there any dialogue in here? So this is what's keeping track of the game loops in terms of when you keep going back to the start. So loops complete might give us a clue if we look for this, where the dialogue is. Here we go. Dialogue, loop 1 dialogue scene instantiate. Okay, loop 1 dialogue scene. Okay, so we've got dialogue scenes. Let's go ahead and check those out. So let's do dialogue scene. This might be the base dialogue scene. And we've got custom resources here that are representing the dialogue entries. And we've also got a bunch of the UI here for the prompt. prompts. So yeah, this is just all stuff that's configurable based on who you're talking to, I'm imagining. We've got the type timer. I think that's pretty self-explanatory. Let's take a look at these scripts. Okay, so these scripts contain, looks like some configurations here. We've got whether it's the NPC or the player speaking, and then we also have BB code in here. So this is probably a rich text label in here. Yeah, this dialog text is a rich text label. So what's probably happening is that these dialog entries, that text value is being read and inserted into that rich text label with the BB code, which I think is a fine way to do it. So let's take a look at the other dialog scenes. So we've got loop 1 dialog scene I think we need to look at. So we've got, where was this configured again? Introduction. So if I go to introduction.tscn, so this is that scene that we go into in the first moment of the game. And this is where we return to after every loop as well. Again, we have very nice God rays, but let's stay on track for now. At this level, we have our loop 1 dialog scene here. So we've got our introduction sign dialog. Let's go ahead and open that scene. So here we go. This is going to load up the loop 1 sign text. So there's all of our text there. Okay, so that's introduction sign dialog. So this appears to be fairly straightforward so far. The developer in submitting this game mentioned that the dialogue system is probably the hardest part because there's a lot of conditionality around it in terms of which dialogue shows up when you go through a certain loop number and which order you interact with the NPCs in. Right now, I'm trying to locate precisely where that conditionality exists. So this loop 1 dialog scene, if we've got loops complete equals 0, it will load that one. So it's loading 3 different dialog scenes depending on which loop you're in. So our third loop dialog scene in our introduction is more of the sign. Okay, so I'm guessing then that this introduction here, if I view this in file system, this is probably one of the levels, and we also have the lab level here. Okay, so there's only 2 levels, I think, which makes sense, I think. So if I open up the lab here, we've got some more dialog scenes here. Terminal 1 dialog scene, terminal 2 dialog scene. So if I open up lab, this is a separate level as well. So it's got its own dialogues in here. Okay, so here's some conditionality around here. Get dialog stage. If current interactable equals interactable type.terminal, we're checking the terminal dialog count and instantiating which dialog should show up. Otherwise, we're gonna look for the loops complete, and this is related to what? Okay, so I see where the conditionality is coming in now. So if we've got 0 or 1 loops complete, we'll just load either loop 1 or loop 2 dialog. But if we've got 2 loops complete and we haven't spoken to the terminal and we can talk to the slime, we're loading loop 2 dialog. So that's being loaded in both cases here. Okay, I see what's happening. So every time you go through a loop, the very first loop that you're on, you're always going to want to show this loop 1 dialog scene. But in here, if you're interacting with the terminal, we're going to spawn terminal dialog scenes. Basically what's happening here is these dialog scenes are conditional based on which loop you're in, but also there's some conditionality around whether you've spoken to the terminal or not. So I think partially what's being confusing here is that these scenes are named as loop 1 dialog scene, loop 2 dialog scene, but these don't necessarily have to spawn during loop 2. So I think one easy way that you could clear up what's going on in this block here is just to rename these members here to be more descriptive of what they actually represent and to sort of decouple their naming from the loop that they're in. I know that sounds kind of trivial, but it can honestly help quite a bit in your ability to understand what's going on, even if you're the developer, right? If you name your variables with clarity, it makes your code and thinking about your code much easier, at least in my experience. So honestly, I'm looking at this and I understand how this could be a little bit tricky to manage, especially if it was to grow. But honestly, for a jam game, I think that this is mostly fine. I'm not really able to come up with an obvious way that you could improve this beyond, just the simple thing of renaming these. One way that you could maybe improve this is by using a state machine for which dialogue options are available. But honestly, that might be overkill. I think just if and else if statements would work just fine. Now that I'm thinking about it, I think maybe something like, rather than a state machine, something like a decision tree might actually be best for this. I haven't really written any dynamic dialogue systems that have a lot of conditionality, so this is actually kind of a fun thing for me to explore as well. But a decision tree is basically exactly what it sounds like. It's a tree where as you go down the tree, certain conditions are met and that determines which path you branch down the tree. I'm wondering if there's an easy way to do that. So I'm actually going to see if I can find a decision tree NuGet package that's easy to pull into C#. Actually, you know what? Rather than a NuGet package, I'm going to tell the AI to write an implementation for me. So I'm going to go ahead and open up my Copilot here. We're going to use Claude Sonnet 4 Preview. Why not? And what I'm going to do is I'm basically going to say, I need a decision tree implementation designed to make determining which dialogue scenes to spawn easier. I'm looking for an implementation that makes adding conditional and branching logic easy and will ultimately return the proper packed scene for the proper dialogue. Can I add, let's see if I can add this to the context here. Yeah, let's just see if this works. Create a class implementation for this decision tree, but do nothing else. So this is a great application for AI too, is you can have it just analyze your code and tell you some better approaches for doing things. Or I wasn't able to find a very easy to use decision tree implementation in NuGet. So I decided to come to the AI and say, hey, write me an implementation so that I can use that. So we'll go ahead and wait for this to do its thing. Okay, so this looks like it has generated a pretty good decision tree here, and it also gave me an example of how to use it. So all the nodes in this decision tree are decision nodes, but we have notably condition nodes and result nodes. So the condition nodes are accepting an action or a condition that can be evaluated, and it has a return type of bool. And those condition nodes will ultimately feed into this .then here, which will return a result node. And we can construct result nodes by doing decision tree.return, so on and so forth. So it's very simple. It kind of compresses the logic down and makes it a little bit more manageable. But the other thing is that you can nest these multiple levels, right? So it's a little bit easier to follow the logic. Again, I'm not entirely sure that this is going to be something that's very useful to do in this situation, but I figured let's explore decision trees a little bit and see how it works. So I'm going to attempt to construct the decision tree based on the example that's been given to me here. And let's just go ahead and do this. Var dialog tree, and you probably wouldn't want to create this dialog tree every time you call get dialog stage. You could probably create this ahead of time and store it, but that would require that you create certain functions that are not only reliant on this scope in here, which is kind of beyond what I'm trying to do here. So let's just do this. New decision tree, and we're going to do .setRoot. And then in here, I'm just going to follow this example here. So decision tree.when, and in here, instead of doing game conditions.terminal dialog count, that's assuming that I've created a new game conditions terminal dialog count function in here. But in this case, I can just write a function myself. So we'll say when current interactable equals terminal. Okay, and then what I can do is I can do a .then. Then we want to do another decision tree.when in here. And we'll pass in gm terminal dialog count is equal to 0, like so. .then decision tree.return. And this is going to be terminal dialog scene 1 .else terminal 2 dialog scene. So does this make sense? So basically what's happening is we're checking, okay, decision tree when current interactable is equal to interactable type.terminal. Then we're going to go into a decision tree, another condition. We're going to see when the terminal dialog count is equal to 0, we'll return dialog 1 and dialog 2 otherwise. Now, what you might be saying is, hey, this is functionally not different from a if-else block, and that's true. But what I would point out here is that this pattern here becomes a lot easier to make configurable with some kind of config file. So you could construct a dialog tree more easily from a config file that you could configure through the editor. So if you wanted to support a bunch of editor tooling to define the conditions when certain things happen, this can be more easily dynamically generated from a config file, in my opinion. But in any case, let's just go ahead and finish this out. So what you end up with is you end up with something that's a little bit more compact than the if-else blocks here. And you end up with something that's a little bit more configurable. So if you wanted to make this configurable through the editor, you could easily imagine a situation where you could have a JSON config that defines all the conditionality around when certain dialog actions happen. And then you could easily parse that JSON into this dialog tree object. So that was a little bit of an interesting exploration into decision trees. Again, in this example, there's not much of a benefit using this over using just these if-else blocks that you've got here, other than maybe it looks a little bit clearer what's going on. So yeah, this is basically going to come down to a matter of personal preference. I do think that probably a decision tree approach or similar approach to handling this complex branching logic is going to be easier to work with in the long term, especially as you get into situations where you've got more and more nested conditionality in your dialogue system. But like I said, this is just a game jam. It doesn't have that much complex dialogue here. So what's written here is, I think, perfectly acceptable. Aside from some minor stylistic issues that you might have with it, it's functional and it's exactly the right approach, I think, for a game jam game. Let's go back into the project here and let's just poke around a little bit more and see if we can pull out some other interesting findings here. What I'm really curious about is I'm curious how this crate works at the beginning. So this crate falls down and gets destroyed and then spawns the player. So I'm wondering how that's happening. If I look at my destructible crate here, maybe that's not actually the place to be looking. Let me actually go back to introduction here, and we've got in here props. I actually don't know where the crate is coming from. Let me go to the script and see if that's being instantiated anywhere. Okay, so we've got a spawn character function here. We're adding the child character position. Spawn character at crate destruction point. Okay, interesting. Oh, I see. So the character is being immediately spawned if the red door hasn't been opened. Otherwise, we're spawning the crate, add child. I see. What I'm not sure about is how, after this crate is spawned, I'm not seeing anywhere how the player is actually spawned in here. So spawn crate is called up here, which is fine, but I don't know how that's ultimately spawning the player. Let's take a look at this crate scene, which I believe is an export variable. Let's take a look at what that scene is. Crate scene. Okay, so this is not the destructible crate. This is a crate by itself, although there's no reference to the player in here either. So how is this actually working? I'm actually kind of baffled. So let's actually do this. Let's go into the ready method here, and I'm just going to go ahead and put a breakpoint. I'm going to see if I can debug this. And I actually don't have debug configured, although it looks like maybe it's working now. Let's see. Okay, there we go. It seems to be working. All right, so let's go ahead and see. So we've got initialize variables. What is that doing? Okay, that's not doing anything related to the player. Connect signals. Oh, signal manager instance on crate destroyed. Oh, interesting. On crate destroyed. And it's spawning the character here. Okay, I understand. I didn't even need the debugger. So crate destroyed, where is that being called? Crate destroyed. On crate destroyed event handler. So we've got a signal manager here, which is fine. I think that having a global signal manager can be a really good idea when you need to make your game aware of certain global events, is the way to think about them. There's a crate destroyed event handler here, and this is going to be calling emit crate destroyed, probably from when that destructible crate is destroyed here. Yeah. And that's emitting its center position. Now, in this case, I wouldn't use a global signal manager. If this is the only place where crate destroyed is emitted, then I probably wouldn't do that through the global signal manager. If I go to my introduction here, what I should be able to do is when I spawn the crate here, this is being instantiated as a node 2D. So the problem again is that the root node of that crate scene is not the destructible crate. But ideally what you'd be able to say is like destructible crate is equal to crate as destructible crate. That's not going to work because again, this crate is a root node of type node 2D, right? And then this is the actual node that has the script on it. So again, we're running into the problem where if your root node is not the node that has the central script, then that's going to make it really difficult to work with. I would just elevate this to the level of root node, honestly. I don't necessarily even know why this crate scene has to be like that. I'm kind of interested, actually. I'm going to try something. Instead of having the crate here, I'm going to quick load destructible crate inside of there instead. And then what I can do is I can instantiate that as a destructible crate. And now what I can do is I can connect to that signal here. So I can do crate dot, and we don't have a crate destroyed signal in here. So it's probably only emitting the global version. So I would just get rid of the global version. I would just do a signal up here, signal public delegate void destroyed event handler, vector2 center position. And then I can just emit that down here. And by the way, you can do this too. You can do emit signal destroyed. The C# source generators automatically create methods to emit every custom signal that you have. So you could do emit signal destroyed there. And we can pass in the center position like so. And then in my introduction here, I can do crate.destroyed plus equals on crate destroyed. And that should be functionally equivalent. So if I go back into Godot here and I run, we should see that I'm still getting spawned. Yeah, so that works exactly the same. So there really was no reason to have that crate scene at all. So that can actually probably be deleted now. And there's no reason anymore for that signal manager to have this crate destroyed as a global signal. But again, what you could do here is these could all be replaced. So this could be emit signal stage completed. on stage completed like so. The nice thing about using the C# source generated version of emitting the signals is because that will give you the types that you need too. So now it's going to enforce that I need to pass in one string argument like so. If you do it like in this fashion, Godot doesn't know and C# doesn't know what arguments are required to satisfy that signal. So it's just nicer to do it this way. But otherwise, yeah, I think this is fine. Again, I think a global signal manager is a great idea, especially if you need to be notified. For example, in my game Gunforged, I have enemies that are dying all over the place that need to be listened to by the player's weapons so that they can respond in a certain way. That would be a nightmare to hook up without a global signal telling me that an enemy has died. So I definitely think that this can be a very useful pattern, but you just have to be careful and I think use it sparingly. Use it only when you know you can't establish a direct connection or you have multiple different parts of your code that all need to listen for the same signal. So that was Echo. Thank you so much to the developer Papa Laquavius on itch.io for submitting it. It was a fantastic project. I really enjoyed looking at it, and I hope that you all found this interesting and enjoyable. Let me know in the comments below what was the most interesting thing that stood out to you. And again, please check out the developers' links. Those are in the description below. And also check out my Udemy courses and my game Gunforged. Those are also linked in the description below. They're a great way to support me. Thank you, everyone. Thank you for watching, and I will see you in the next one. Thanks for watching this video. If you want to support my work, you can purchase one of my courses, you can purchase my game Gunforged on Steam, and you can sign up for my email list at firebelly.com. All the ways that you can support me are linked in the description below.